thought about how to introduce this topic, and I like to explore things. Tonight I'm here to explore agility for hardware together with you. But otherwise I like to explore routes like this when I go on my motorcycle. And obviously, as you can see on these roads, I need to have an ability to turn quickly on these roads. Otherwise I would end up on outside the road, and that is not a good thing, especially not if you're on a motorcycle. So if we consider, instead of being the rider on that motorcycle, considering the company that build those motorcycles, including all the hardware and software, everything related to build a good motorcycle that really fulfills the needs of those customers, how can we make those companies turn quicker? When you consider those companies that build motorcycles, you might consider them more like not a motorcycle, but maybe more like a bus. There is a driver in front that hopefully has an idea of where to go, and there is a bunch of people in that bus that might want to go in different directions. And when the bus moves on the road, it has probably need to go quite slow. Otherwise, if it turns too quickly, it will end up in the outside the road. So how do we make these buses like those companies that build motorcycles turn quickly? First of all, I have no intention of actually being able to bring a comprehensive and correct, or maybe partly correct, but not a comprehensive and full view of this in this presentation. See it more like what is in my mind about this topic right now. And why I can't give you the full answer of this is because it's a quite complex topic. We build products that are getting more and more complex in both hardware and software. And that also means that the organizations we need to be ordered to build those products are getting more and more complex, and the way we work are getting more and more complex. So how can we be in a reality like that and still be able to gain speed and flexibility? Because if we look around us, that is probably what we see happen right now, that companies need to be more and more flexible and more agile and do things in a quicker pace, otherwise we are out of the market. So we need speed and flexibility, and how can we apply this in a context with hardware? That's the question. We have been doing it within software for some time, using agile ways of working and creating agility in different ways. But can we really use the same ideas when we apply to hardware? That's the question. I've had the opportunity to work with a few companies around this topic, and I've come across some questions that usually pop up. One of those questions is, we can't, or statements rather, we can't have cross-functional teams. We need to be so many people to create some kind of cross-functionality that we would end up with a team of 2,000 people or something. But let me remind you that quote I showed you before, this one, about speed and flexibility. That quote was actually kind of the inspiration for when Jeff Sutherland created Scrum. There were two researchers called Takeuchi and Nonaka that has done quite a lot of research around innovation in companies. What makes product development companies more successful than others? And one of the things that they actually found in those companies that they used cross-functional teams that were able to take the project together towards a goal where they had different expertise from different parts of the company. And so that is really where the idea comes from. And those companies that were studied in this paper from Harvard Business Review, it's from 1986. It was companies like Fuji, Xerox, Canon, Honda, NEC, a lot of both Japanese and American companies. And it was all about hardware. it was not so much software related on that in 1986. So actually many of the ideas that later inspired agile within the software world, those were ideas that has come up in the hardware world from the beginning. So if you are into hardware, you don't need to go to the software guys to understand this. You can just look into what has been done in your own world, so to speak. So that is one thing that pops up into my mind when I get that question. We can't be agile within hardware. We have the next question or next statement here is that we can't build potentially releasable products in small increments, because it takes several years to get a motorcycle out there so that anyone can buy it and we get the value to the customer. And before we do that, we don't deliver any value. Okay, but in agile ways of working, we say that we should deliver value incrementally and continuously to the customer. Okay, so let's see, why do we need to deliver value continuously to the customers, do you think? Is it only to make the most profit in the shortest possible time, do you think? Or is it something else? Maybe it is to be able to learn what these customers really need and want. Maybe we need to learn can we actually build these motorcycles? We have a lot of hypotheses that we need to confirm, because if we can't confirm them and learn about how to solve all those problems, then we will probably end up with a not so successful product. So that is why we have come to use in the agile software world these feedback loops all the time. We need to learn and to confirm our hypothesis. And if they are proved to be wrong, we need to adjust our direction. So that is how we learn. And that is built into agile ways of working. So one of the important purposes here is to get learning. And of course, the ultimate way to learn if we can fulfill the customer's need or not, it is to actually put something out there that the customers can use. But even if we can't do that, that doesn't mean that we can't learn when we develop our products, and that we can't use feedback loops when short feedback loops when we develop our products. So let's see. What kind of hypothesis do we need to actually validate when we do development? It could be things like, does it really have a proper fit or purpose, this product, or will it yield a quality outcome? Can we actually get enough quality in it? Can we produce enough value from it from a life cycle perspective of the product? So let's look into a typical product development process. Of course, it's much more complicated than this, but this is just a very, very simple summary. Usually we start with defining and understanding what do we need from the product, define the product, what do we think that we need to build and how to build it. And then we create the product, and after we have created the product and all the drawings are there and everything, then we can start to prepare for production and to get everything on board with suppliers and to order the tools and everything. And that, I draw a line here, because after that line, then it's when things are getting really, really expensive. And we need to be ready for start of production, of course, and we can't be late, because we have many people may be relying on us that we were actually able to meet that delivery date. Otherwise, our marketing people and a lot of other people would have big problems. But what maybe happen then is that, we work here and we think, we have a plan and we work on, and then we realize, we are not ready yet. So what do? We need to work harder. Can we bring in some more people? And really we work hard here in development to be able to deliver this product in the end. But then, as if we can't make decisions on how maybe to cut scope or anything, and that is really hard, we could end up in a situation where actually all those prioritization decisions, there is someone making those decisions for us, and that is time.
13 november 10:53 och 10.
So the product needs to be there at launch, and time has made the decision for us. So we launched the product, and yeah, everyone is happy, and everyone that has to work really hard all the time in the end, they are seen like heroes because we were finally able to deliver this project once again. But the problem is that what were the consequences of being late here and not being able to get everything ready in the state where we like it? What is the consequence of that? We can see it in a number of different ways. What happens when we don't have enough time in the end? Yeah, we can see it that maybe in quality. We can see that people get burned out. We can see that maybe when we need to put a lot of resources here to fix all the problems here, we didn't have time to do what we should do for all the other projects we were working with that were in earlier phases. So if we look into this, when we do this firefighting here in the end, then what happens? We can look into it from a perspective of how much does it cost to do feedback loops. If we look into this typical project here, we can see that here in the beginning, it's more like the software world. It's quite cheap to do small feedback loops. But then as we move on here, it gets more and more expensive. And when we have come to this phase here, then it will get really expensive. We can't do a lot of feedback loops there because we can't change the tools and everything. It will be so expensive. So we want to avoid that. But if we look into what a traditional product development company usually do, is that where they actually put all the efforts into working in kind of a feedback loop way, it's here in the end, when we get into the problems. We just hope that the plan would work and that we were planning in a good way before we reach this point here, but then when we realize, it isn't working as we thought, then is when we bring all the people into firefighting mode and start to do feedback loops and work in kind of an agile way. I would not call it agile, but agile with quotes, to get things ready before start of production, because we have no other option. We need to be ready. So, what if, I should mention also that what we actually do then is that we buy cycle time when it's most expensive to buy cycle time. So what if we could instead be able to buy cycle time earlier here, instead of doing it regularly in the end here? And this is not unusual. It happens in many product development companies that this is something that happens in project after project, that we buy cycle time when it's most expensive to do that. So maybe we should see if we can buy cycle time earlier and to do feedback loops when it's less expensive. And that is one thing we need to understand when we work in the hardware world, that in the software world we have come quite far in being able to make these feedback loops quite cheap. We can actually have software teams that deliver every day and every hour and out things to the customer, and it doesn't cost us much to integrate the product and get it out there to the customer. But in the hardware world, we come to a point here where it's a much more complicated issue where we to integrate the product usually, and it gets really expensive. So if we look into that, when it is expensive to do these feedback loops and get the product out there integrated, it doesn't make economical sense to do it only here. We should focus on doing it a lot more here, so that we end up here with much better knowledge of how to build that product in a good way. So we need to think about it more like getting out value. It's the purpose of it. Part of the purpose is to actually gain knowledge of how to build the product here. And so that is what we should focus on when doing all these small feedback loops here, to gain as much knowledge as possible. So that could be the definition of how we create value.
Would you like questions now as you talk, Christian? Or
Do we have a question?
I just want to sort of private.
Yeah, I have a Q&A session afterwards, so we can take this session. Even though it might be a bad thing to build up a big batch of things, we could maybe have smaller batches, but this time we'll have a Q&A. Yeah. Okay. So the next thing, or maybe the question we could ask to ourselves is, what is the cost of integrating the product or update a model or whatever we do to get that learning, compared to the cost of delaying that learning? What is the cost of actually not getting the feedback we should get from the customers, or from whatever way we do to confirm our hypothesis? It could be a technical hypothesis as well, to see, can we build this product in a good way? Can we manufacture it? Can we do it to a cost that makes it good from a life cycle perspective of the product? Okay, and we can, if we see that we have quite a high cost to get those feedback loops, it's not like it will always be that way. We can actually have different ways of dealing with that situation. We can, of course, focus on the knowledge building. How can we do that? There are, apart from doing these feedback loops when we work, we can also use other approaches like set-based concurrent engineering, where we use different concepts and work with them in parallel, and we don't choose the one concept to continue with until the last responsible moment, so that we have gained as much learning as possible before we end up with the chosen concept. That could be one way to do it. We could move functionalities to software, of course, where we have another economic equation that looks different. We could invest in new technology. Of course, there's a lot of technology available to be able to get more feedback. We could use simulation. We could use, there is actually continuous integration for hardware as well. From a virtual point of view. We could use technology like 3D printing. We have a lot of people here in the room here. I know that work with that technology. So and you will hear more from that from Ulf later on. We could reduce complexity so that we can be able to test modules without having to rely on integrating the complete product. And we can also understand how to collaborate with suppliers, because that is also quite important. Because one of the usual things I also hear is that we can't be agile when we work with suppliers. Okay, so let's give you an example of how things could work out if we don't have a good way of working with suppliers then. This is a quite nice airplane. It's the Boeing 787. When that was introduced quite recently, it was it was full of new innovation, new technology like carbon fiber and a lot of things. So it was really a breakthrough in that regard. But it was another thing that was maybe different with that plane was that it was much more of that airplane was outsourced to suppliers than normally. Instead of having 35 to 50% outsourced, it was around 70% that was outsourced to suppliers. And by doing that, Boeing thought that they would be able to shorten the development time from 6 to 4 years, and the development cost from $10 to $6 billion. But the end result was quite the opposite. It was billions of dollars over budget, and 3 years behind schedule. And you've probably heard a lot about the problems with batteries and other things that have these planes grounded for some time. So, in the effort to reduce cost, they actually ended up in the opposite. And regarding what they actually ended up in a situation like this when they did innovation, where they outsourced the innovation to the suppliers, they actually ended up with maybe a lot of profit for the suppliers in the end, when they had to adjust to when they gained the knowledge and realized, oh, we are not on track here, and they had to work and adjust to get more business for the suppliers to get good in the end. But also that the knowledge was actually not didn't stay or actually wasn't acquired or learned inside Boeing, but at the suppliers instead. So that is maybe something to think about when it comes to innovation and how to work with suppliers. But what is kind of confusing here is that what Boeing did was to get inspired from Toyota, because they have a strategy where they outsource 70% of the car to the suppliers. But what they forgot to do was to see what Toyota also did when they work with suppliers. They brought in this model, but without bringing in the values and principles and practices that model relies on. And that is about face-to-face communication and such things, and to share the values with the suppliers, and to build trust, and to only work with suppliers that have a proven ability to deliver on the required timelines, cost and reduction, and building a long-term partnership with those. So that was a mistake that Boeing did. So when we work with supplier, we should consider how is this related to our process of knowledge creation, and how we do that in our companies, so that we understand that when we do innovative things, we need to be able to have these short feedback loops together with the suppliers in a good way. We could do that either by having a good partnership with the supplier, or the option might be to actually have those development going on inside the company instead of not outsource it. So that is maybe a learning from Boeing. But I told you, this is about knowledge creation, it's about maximizing learning. So that is how to understand how we actually maximize learning and how we learn in the organization. That is one really important thing that we need to understand if we want to bring those agile ideas into our company when we work with hardware as well. It's important for software as well, but maybe it is more clear that we need to understand this when we work from a hardware perspective, because we don't have that way of actually getting value out to customers directly in the same way. Another thing we need to understand is flow. We need to understand how to optimize the flow, how to prioritize based on things like cost of delay, how to get a good flow by not working with too many things at the same time. We need to understand how batch sizes affect our flow. And all these things are not only related to software again, it's something we can apply very well in the hardware perspective as well. We also need to understand the economics of product development. We need to understand that when we make decisions, we need to include all the relevant parameters, not only cost of and part price and such things. We need to understand the complete picture, what gives value and the economy in the product from a life cycle perspective, which is including development cost, production cost, unit cost, delivery cycle time, and value delivered. And delivery cycle time is actually quite important, because that is something that is quite common in large organizations. We have a lot of dependencies and we don't see really what happens when we put that extra work here inside our organizations. How will that impact the flow and the value we will actually get out in the end? So there are a lot of things we need to understand, and we also, of course, need to understand people in the knowledge organizations and in the product development organizations. How can we actually understand how the benefits of moving decisions to the teams, to those that have the knowledge, to do that and still being aligned on a common purpose and avoid sub-optimization. We also need to understand what motivates those people, because if we are giving them the responsibility, and it's really important that they are motivated. So, and we have another thing is that if we want to work in a good way where we can learn all the time and hopefully discover problems on the way all the time, we also need to understand how can we build trust in this system? How can we make those people bringing up all those problems that they find, and actually having the courage to say when things are not all right? Because it might be a really important project here, and we might delay it if we bring up something that might stop it. So maybe it's more safe to just not say anything. We need to understand psychological safety, and to, as leaders here, we need to understand how to make it safe to fail for these people as well. Otherwise, those problems will not come up, and we will never learn, and we will fail probably in the end. And this is a lot about leadership. So I would like to just highlight a few things here. We have something called the safe, lean, agile principles, and those are maybe the most important things from what I think, at least, in SAFE. And if we look into these, those can be really useful when we explore these ideas and how to do what I actually talked about earlier. And especially important when we work with hardware, because we won't have all the answers presented to us in the safe big picture, and that will work right out of the box. It will probably not for a software organization always as well, but especially important when it comes to applying this in a different context than we are used to. We need to understand the underlying principles, and we need to see, okay, think about how can we apply them in our context. But we don't have to go very far to actually understand that from a hardware perspective. It's just about looking into those principles. We have this one, for instance. Unlock the intrinsic motivation of knowledge workers. That is to quite a large extent inspired by the work from those researchers, Takeuchi and Nonaka, and they have done a lot of great work in this area. There are, of course, a lot of others other thinkers to learn from here as well, but I would like to highlight that these people are not from the software world, it's from the hardware world, actually, from the beginning. We have 3 other principles: take an economic view, visualize and limit working process. That is about the flow I mentioned. Apply cadence with synchronized with cross-domain planning. Then you should look into Donald Reynerson that wrote this book. That is really essential reading, and it's all about hardware almost. It's about building things. So the thoughts and ideas in that book that actually is very much part of SAFE comes from the hardware side, from product development in hardware. And then we have this guy, Deming, that maybe you know, that inspired these 2 principles. If you read his book, Out of the Crisis, you will not see so much about software organizations. You will see a lot about quality, and you will see a lot about systems thinking, and you will see maybe a few examples from hardware as well. So this is not only software related. And then we have Alan Ward, that inspired these 2 principles. He has done a great work of understanding how Toyota works and works with their suppliers in the area of lean product development. And so you can read his book. and you will see a lot about building airplanes and cars and other hardware. And finally, back to the motorcycles. We have Dante Rostoval who inspired these two principles. Actually, his book is about his journey. He started at General Motors and then came to Harley-Davidson and changed how they work in their product development. So what you actually see here, that's everything almost that actually is the thoughts and ideas in SAFE are very much inspired from hardware people. So, back again. So if we need to build better, if we get speed and flexibility, how can that give us some benefits in our organizations? Well, we can build better systems faster, hopefully, build better product faster, hopefully, and that could help us to hopefully become better in the marketplace and compete with all our competitors out there. So that was what I had to share with you today. We are a little bit late, as we started late, but I think we can, what do you think? We can have a shorter
You won't
break.
get away from the questions, sorry.
Yeah, so
If there are any.
So we spend a few minutes for the questions as well.
Please
Yeah.
bombard him with
Yeah.
the questions,
Yeah.
thoughts, ideas, points, remarks, clever comments. Anyone? Sir?
Okay, thank you very much for the presentation. And my question was regarding the feedback loops, and
Yeah.
if you can share some ideas on how to implement these feedback loops. I think you already
Yeah.
mentioned,
Yeah.
but if you can elaborate more on that.
Yeah. One way to do that is to think about how can we actually get some validated learning from whatever we do. So instead of just defining, okay, we have all the activities we do and put those in the backlog, we should think about what is the expected outcome of those activities. Why do we do them? What do we actually want to get confirmed by doing that? What do we need to learn? So that could be a starting point to actually see how can we look into this like a hypothesis. How can we learn? How can we see that we have validated that hypothesis and learn from what do we?
So identify the purpose.
Yeah, identify the purpose might be a starting point. Yep.
Thank you. Someone else? Something else? Talking about listening to what you said about Boeing there, what had they learned? How will they proceed from here? You said this was 787 was quite recent.
Yeah. Yeah.
Where and how will they go from there?
Yeah, I don't know the latest status about that, but I think I hopefully hope they will learn, because otherwise they will end up in. I mean, when a airplane project goes wrong, it's quite expensive, so it will really put the company at risk. And I think I heard a story about the CEO of the company at that time when they started that project. It's about in the early, like 2001 or something, and he decided that to move the headquarters of the company to I think it was Chicago, because he didn't want to bother with engineering people and to talk about those things, and he didn't want to bother with meeting customers and such unimportant things. So he thought it was more important to actually be able to meet other CEOs of other companies in other businesses, and he could do that in Chicago. But maybe that is not the best thing to do, but when to learn what do our customers need, and what are those technical hypotheses we need to validate, and those things. All right.
So basically what you're saying, Christian, is that the foundation that we have for not just lean product development, but also agile development is not only the right things when it comes to software, but also very much the same thing goes for hardware development.
Yeah,
Is that right?
but we should always remember that we need to think. We can't apply these ideas just by looking into the cookbook and then follow the recipe. We need to think as well. And that applies to both hardware and software. And I think maybe that makes it easier in hardware context because it's so obvious we need to think. When we apply the ideas in the software world, we might just think that, yes, apply them, and then we're fine because there are so many other companies that have done that.
It is tricky, and therefore you guys are needed, right? If it wasn't tricky, anyone could do it. Right? If
Right.
no more questions, thank you very much, Christian.
Yeah.